Hello and welcome to this lecture where you are going to learn the basic intuition about tracking algorithms. First, you will understand the intuition and then we will implement them step by step using Python and OpenCV library. We have this image here where the goal is to select the runner and track him to the end of the track. There are two important concepts that are used in almost all tracking algorithms. The first is called motion model, which is a combination of location and speed in previous frames. So, based on location plus speed, it is possible to predict the next location of the object in the next frame of the video. We have the current frame here with the bounding box around the object, and the prediction will indicate that in the next frame, the object will be in that part of the track where I am pointing the mouse. The second concept is the appearance model, which, as the name suggests, is responsible for storing the object's appearance or the shape to search for locations close to where the object will be in the next frame, the nearby positions. Some searches will be performed around the object where I am pointing the mouse to predict the next location and speed. Let's suppose that in the next frame, a car appears in this position. The appearance model will check that the appearance of a car is totally different from the appearance of a person. They have different shapes, so the algorithm will continue tracking only the person. Here we have a summary of these two concepts. The motion model predicts the approximate location of the object. The appearance model adjusts the location to provide a more accurate location based on the appearance of the object. And in general, algorithms use both techniques together, the motion model plus the appearance model. The purpose of a tracking algorithm is to classify a rectangular region as an object or the background of the image, which is everything in the image that has no relation to the object that we are tracking. For example, in this image, several bounding boxes will be created here, here, and here. And the algorithm will receive an image patch as input. This is a terminology that represents information about the pixels of the images. And it will return a value in the range from 0 to 1 that represents a probability of the area being the object or the background of the image. The closer to 1, the more likely it is to be classified as the object. On the other hand, the closer to 0, the more likely it is to be classified as the background. Each one of these rectangles is an image patch that will be sent to the algorithm, and then we can get the probabilities. For example, 10% here, 80% here, and 10% here. As the person is in the central part of the track, we have a higher probability in the middle box, which is the real direction of the object and the prediction of the algorithm. So, in short, the algorithm will receive as inputs the image patch of the surrounding possible positions that the object could go, and will generate a probability for each one of them. And the highest value will be the selected location of the object in the next frame of the video. Tracking algorithms can be developed using two machine learning techniques, online learning and offline learning. Most algorithms use the first approach. They are trained in real time and at runtime. The training starts when the algorithm is executed, and all mathematical calculations are done during execution. On the other hand, thousands of images are needed to train an offline classifier. For example, to track cats and dogs, it would take thousands of images of cats and dogs, so the algorithm can learn from the images before tracking them. Online learning is faster, and training starts when you select the object you want to track. In the next lectures, we will implement so it will be easier to understand. And that's all for this basic content about object tracking algorithms. And in the next lecture, you will start learning the intuition of some tracking algorithms. See you there!